All right, guys. Fundamental theorem of algebra tells you, guys, if I have x to the fourth, how many zeros do I have? 4. I have 4 zeros. I have 4 x equals. Some of them might be real. Some of them might be imaginary. They all could be imaginary. They all could be real. But what the fundamental theorem of algebra tells you is the highest exponent tells you how many answers you should have. I've told you guys that since we started. We've already been talking about the fundamental theorem of algebra. When I talk about linear factorization theorem, linear. If I talk about linear, guys, what's the power of x if I talk about linear? Yeah, x to the first power. If I talk about a factor, what does factor mean?
It goes into something.
Okay, it goes into something times something equals. So, if I asked you guys, let me think about this. 7x plus 10 equals 0. If I said to you guys, what are the zeros? What are the solutions? What are the roots? What would you tell me? What times what gives me a 10 when I multiply and a 7 when I add?
5 and 2.
X plus 5, x plus 2. So what are my zeros?
X is equal to -5 and x is -2.
Okay, everybody in here can do that, no problem. These are my zeros. These are my answers. What can you tell me about these zeros? Are they both real? Both imaginary? One imaginary, one real? What's up?
They're both real.
They're both real. That means when I graph this parabola, it's a parabola because it's x squared. It's going to touch the x-axis at -5 and 2. When I talk to you guys about the linear factorization theorem, when WebAssign says write this polynomial as a product of linear factors, this is what they're talking about. Linear means x to the first. Factors means what did I multiply? What parenthesis times what parenthesis did I multiply to get here? So you guys already know how to do linear factorization. You do it every single time you factor. You have to figure out what times what gives you 10 but adds to give you 7. You get your 2 parentheses, then you solve them. When you factor, this step right here is your linear factorization. You guys already know how to do this. So in WebAssign, they're going to ask you, the first question might be this. Letter A says, write the linear factorization. All they mean is what parenthesis times what parenthesis gives me the polynomial. Then when they ask for the zeros, the solutions, the roots, they want to know what does x equal. You go one step further and solve. All it is semantics. It's just knowing what vocabulary words they're talking about. But this is our linear factorization right here. What factors do I multiply together to give me the polynomial? Does that make sense?
Yes.
Okay, is okay with that? All right, so let's just go through. I've talked to you about this before. Did I white this out on your notes, or do you guys have the answers here?
You whited it.
Okay, all right, because there's part of it that I whited out and part of it I didn't, but I'm going to go through it. First degree polynomial. First degree means the highest exponent is what number? 1. So if I said to you guys, what is the 0 of this function, you would tell me it's x equals 2, correct? You guys agree with me?
Yes.
Okay, look at number 2, or B, whatever. I have x squared. That means how many answers should I have? 2. So the first thing I'm going to do is, okay, well, what times what gives me a positive 9 when I multiply, but a negative 6 when I add?
-3, -3.
-3, -3. That is your linear factorization. If they asked you to write the linear factorization of this polynomial, well, what do you multiply? What times what gives you x squared minus 6x plus 9? Then if they said...
Sorry.
Go ahead.
Wouldn't you leave it like that if it was asking, like...
If they asked for the linear factorization, yes. If they ask for the zeros, if they ask you to solve, you would say x equals 3 and x equals 3. So now I can ask you a bunch of things. I can say to you guys, is there multiplicity?
Yes.
Where?
2. Multiplicity of 2.
Okay, at what point?
-3.
At what point? Positive 3, right?
Equals 3.
Okay. What's it going to do? What's this parabola going to do at x equals 3? Is it going to go through, or is it going to touch and turn?
Touch and turn.
Touch and turn. Good. Very good. All right, so look at the next one. Third degree polynomial. Well, how many answers should I get when I have a third degree polynomial?
3.
3. So if I'm going to factor this, guys, okay, let's look at this. What could I take? First thing I do is GCF, so I can take out an x, right? Then I'm left with x squared plus 4 equals 0. You guys agree with me on that?
Yeah.
Okay. Now, if I asked you to write the linear factorization, I think the easiest thing to do is to solve this first, okay? If there's 2 ways they're going to ask this. If I ask you around the reals versus, well, we'll talk about that in a second. All right. Do you guys agree this is a linear factorization? Can I factor x plus 2, or x squared plus 4 anymore and get a real answer? No. If I solve this, I'd say x equals 0, x squared plus 4 equals 0. I'd get x squared equals negative 4, square root, right? X equals plus or minus 2i. Agreed?
Yeah.
Okay. You could write this as x times x plus 2i and x minus 2i. Could you not?
Yeah.
Here's my linear factorization. What times what is going to give me this polynomial?
The x times the other x.
This whole thing. If I multiply that back together, I'd get x cubed plus 4x. How many real solutions do I have here?
1.
1 real. Whoops, what are these?
Imaginary.
Imaginary.
Imaginary. So how many times is this going to cross the x-axis?
Once.
Just once. Cannot touch at any imaginary points. Okay? You're just deconstructing. You're making sure things can break down. What about this one? How many answers should I have here?
Matters.
What's up?
Take out the x.
How do I split which two? The plus and minus I? 2i?
Plus the x minus.
Okay, so say this says x equals positive 2i, right? And then I have x equals negative 2i. Well, Deanna, if I was going to work backwards, and move this to the other side of the equal sign, positive 2i becomes what?
Negative.
So this would be negative 2i. Do you see all we did was just work backwards? What would I do with this negative 2i? I'd move it this way, and it would become x plus what? 2i. You're just working backwards. Yeah, because, well, not that because it's positive. This is not the difference of perfect squares. Lots of times you guys see that and you say x plus 2, x minus 2. Difference of perfect squares, remember, has to have a minus sign in the middle. If there's a plus and each term is a perfect square, then you're going to have imaginary solutions. All right, let's go down here. How many answers should I have?
5.
How do you know that?
Because
5 is large.
it's the highest degree.
Okay, good. So first thing we look for when we're factoring. We're going to do all sorts of factoring. So what's the first thing I look for?
If it's
The
back-
GCF.
GCF, okay. What can I take out of x to the fifth and x cubed?
X cubed.
Okay, if I take out an x cubed, I'm left with x squared plus 9, correct?
Yeah.
Well, guys, think about this. Just looking at this, you should be able to tell me how many real solutions I have and how many imaginary ones I have.
3 real solutions.
Where it going to be where, Carlos? You're right.
0.
Perfect. And then what about my imaginary ones?
X equals plus or minus 3i.
Perfect. Some of you are sitting here going, how do you know that? Well, write it down. X cubed equals 0. Take the cube root of both sides, right? So x is 0. I have x squared plus 9 equals 0. If I solve that, I'm going to subtract 9 from both sides. I get x squared equals negative 9. Remember, if I have a negative underneath my square root, what do I need to pull out?
I.
An I. So here's my 5 solutions. I have 3 of them that are real and 2 that are imaginary. And again, guys, if you're sitting here going, oh, yeah, I don't remember how to factor this, you need to get on the ball. We need to go through some things. You need to email me, and I'll give you some direction on where you can go, what you can look at. All right.
Miss Meadows?
Yes, ma'am. Understand, all right, again, don't get caught up on vocabulary words, but it says a quadratic factor with no real zeros. What does it mean if there's no real zeros? Algebraically, what does that mean?
There's no real solution.
Okay, there's no real solutions. They're complex or imaginary. What does that mean graphically? If there's no real solutions, what is my graph? Is my function going to cross the x-axis or no?
No.
Correct. All right, so if it says that if a quadratic has no real zeros, it's said to be prime or irreducible over the reals. Meaning, what do you think irreducible over the reals means?
Irreducible.
Yeah, there you go. That's fine. So let's look at some examples here. Again, this is all going to be semantics. All right? You guys have this already written on your paper. I know that. I whited mine out so we could work through it. But if I factor this polynomial, let's think about this. X to the 4th. What times what is going to give me x to the 4th? And I know you're looking at it on your paper.
X squared.
X squared and x squared.
X squared.
Okay. What are the factors of negative 20 that'll multiply to give me negative 20 but add to give me negative 1?
Negative 5 and 4.
Perfect. Negative 5, positive 4. Now, if I were to work this out, if I were to simplify, again, I know you're looking at it so you can see it. These answers and these answers are going to be different. How are they going to be different? Why are they going to be different? What do I mean by that?
5 can bring like actual solutions while 4 can't.
Okay, how come? You're right, Vincent, but expound upon that. I agree with you, but why?
Because like when you like solve for x squared and then you subtract 4, you have a negative under square root.
And it becomes
That's
what? This is imaginary. So I'd have imaginary solutions here, and I'd have real ones here. Because when I solve this, x squared minus 5, whoops, that's not 5, equals 0, right? We add 5 to both sides. So I'm going to get x equals plus or minus root 5. So in my parentheses, I'd have x minus root 5, x plus root 5. Now, when it says over the reals, if you want to factor over the reals, is x squared plus 4 going to give me a real answer?
No.
No. So you would leave your factorization. Whoops. I'm getting crazy with my pen strokes. You would leave your factorization like this. Can anybody explain to me why I would factor out, or I would simplify x squared minus 5, but I wouldn't x squared plus 4 if I'm factoring or reducing over the reals? Why would I leave it there? Talk to me, Carlos.
Because if you sorry.
You're okay. Don't apologize, honey. You're fine.
If you were to multiply it all, that would get you your as far as.
No, I understand. If I fully factor, which we'll in a second, but why did I factor these two, but I left this unfactored? If I'm factoring over the reals, these two will give me a real solution. Will this give me a real solution?
No.
No. Here, you guys have to pay attention, especially on WebAssign. You have to pay attention at what they're asking you to do. If you factor over the reals, you only factor the parentheses, the binomials, however you want to look at it, that will have a real solution. If you want it completely factored, that means I would have x plus root 5. I don't know why I wrote a 2. X minus root 5. And then what would these two parentheses look like? X what?
X plus or
Plus
minus,
2i
yeah,
and
plus
minus 2i.
minus 2i.
That's completely factored. These two are real. You should be able to look at this and say, oh, those two are real, and these two are imaginary.
Miss Meadows.
Uh-huh.
Why does when you do that, why does the 2 get the I but not the 5?
Because if you solve this, x squared minus, sorry, it's x squared minus 5, right? Equals 0. And then the other one is x squared. Let me do it down here. My two factors up here were x squared minus, my two parentheses were x squared minus 5, right? Equals 0. And then the other one was x squared plus 4 equals 0. So if I solve x squared minus 5, I'm going to add 5 to both sides. So I have x squared equals 5. And then I'm going to take the square root, right? So x equals plus or minus root 5. 5 isn't negative. So it's not that there's an imaginary solution or imaginary number in there. When I answer over here, if I subtract 4 from both sides, I get x squared equals negative 4. So when I take the square root, I get x equals plus or minus. There's a negative underneath the radical. That's where the I comes in.
Oh, okay.
So, yeah, no problem. So these are imaginary, and these are real. I mean, root 5 is not a great number. It's some crazy decimal, but it is a number, and it is something on the x-axis that you could possibly... I went from right here, where we factored, right? And then I just simplified. I broke them down. So I went, that's where I got my x plus or minus root 5. And then we had our plus or minus 2i. And I just put them into factors, into parentheses. That's completely factored. And then one step further, we'll give you the zeros, which is what we got down here.
Can I take a picture of that?
Sure. Graph
All
if
right.
you needed to. All right, let's work these. Yes. Whoa.
What digit do I in part C?
Okay, I think we're okay now. All right, so now we're going to factor. I want to write the complete linear factorization, then state the zero. So the first thing I'm going to do, guys, is I'm going to say, all right, is there a GCF? Is there a number or a letter that goes into all 4 of these?
Yes.
What is it? X. So I'm going to take out that X, write it out in front, and I'm left with x to the third plus 3x squared minus 13x minus 15 equals 0, correct?
Yeah.
Now I have 4 terms. Is grouping going to work?
No.
All right. So I still have my x out in front, or I can say up here x equals 0. If you guys want to do, if this is how you want to write it out, that's fine. Synthetic division, 1, 3, negative 13, negative 15. I need the factors of 15, so plus minus 1, 3, 5, 15, right?
Yeah.
Okay, so let's try 1. Bring down my 1. 1 times 1 is 1. 3 plus 1 is 4. 4 times 1 is 4. Negative 13 and 4 is...
Negative 9.
Negative 9. So is that going to work? No. Let's try it. Negative 1. So I have 1, 3, negative 13, and negative 15, right? So bring down the 1. 1 times negative 1 is negative 1. 3 minus 1 is 2. 2 times negative 1 is negative 2. Negative 13 and negative 2 is negative 15. Negative 15 times... Okay, negative 15 times negative 1 is... So I have an x equals negative 1, right? You guys with me?
Yes.
So I'm left with x squared plus 2x minus 15 equals 0. Can I factor that? What are the factors of
Yeah.
negative 15 that multiply to give me negative 15 and add to give me 2?
5 and negative 3.
Okay, so x plus 5, x minus 3. So I have x equals negative 5 and x equals positive 3. Agreed?
Yes.
Yeah.
So they ask me to write my answers as linear factors and then state the zeros. So I've already stated the zeros. I have an x equals 0. I have x equals negative 1. I have x equals negative 5. And I have x equals 3. Okay, those are my zeros. If I want to go back one step and write them as linear factors, all you do is take your 0 and move it to the other side of the equal sign and write it in a parenthesis. So if I move 0 over, does it matter if I have plus or minus 0?
No, you just put X.
I'm just going to put x plus 0. Now, in this parenthesis, if I move this over, it would become what?
Plus x plus 1.
X plus 1. For this parenthesis, if I move the negative 5 over, it becomes?
X plus 5.
And then if I move 3 over, it becomes?
X minus 3.
So this is my complete linear factors. I would say that my linear factors are x plus 0 times x plus 1 times x plus 5 times x minus 3. That will work backwards to give me this polynomial. Then my zeros, my solutions, are when I solve each of those things. So here is my linear factorization. And then here are my zeros. Guys, it's really important that if the question on a test or a quiz asks for the linear factorization, you don't just write the zeros and then circle it and then say, oh, well, I knew what I was talking about. You have to answer the question how it's asked. Two different things. All right, let's go to this one. First thing I look for is what?
For GCF.
Okay, is there a GCF here? Can I take out a specific number or letter of all four? Uh-huh. Okay, for the interest of time, guys, because I want to make sure I get through these other two examples. There's no GCF, so I have to do the factors of 40. 1, 2, 4, 5, 8, 10, 20, and 40, right?
For the sake of time.
For the sake of time, I'm going to start with 4. I would usually tell you guys to start with what? 1, and then I'd tell you try negative 1, and then I would say 2 and negative 2. But for the sake of time, we're going to go this way. So if I bring down my 1 times 4 is 4. Negative 7 and 4 is negative 3. Negative 3 times 4 is negative 12. 2 and negative 12 gives me negative 10, right?
Yeah.
Negative 10 times 4 is negative 40. Did that one work?
Yes.
Okay. For the sake of time, I already knew that was going to work. But I would tell you guys to go 1, negative 1, 2, negative 2, 4, negative 4. So my resulting polynomial is x squared minus 3x minus 10 equals 0. Can I factor this? Are there factors of negative 10 that will multiply to give me negative 10, but add to give me negative 3?
Yes.
What are they?
Negative 5 and positive 2.
Negative 5 and positive 2. So I have another x at x equals positive 5. Agreed?
Yep.
Because if I solve this, I get x equals 5. And if I solve this, I get x equals negative 2. And I have an x at negative 2. Those are my zeros. These are my zeros. If I want to write out my linear factorization, I'm going to have 3 parentheses. And I just work backwards. If I move this 4 over here, it becomes what?
It becomes a negative 4.
So x minus 4.
Minus 4.
If I move this 5 over here, it becomes what?
X minus 5.
X minus 5. And if I move this negative 2 over here, it becomes?
X plus 2.
There you go. That is my linear factorization. You guys see what I'm doing?
Yeah.
Okay, so pay attention to what the questions are asking. Oh gosh, I got 4. Okay. What time is it? We're okay. All right. GCF, yes or no?
No.
No.
But you can factor it.
What can I factor this into?
It's
X squared.
X squared plus 1.
Okay, x squared plus 6 plus 1.
Yeah.
If I was going to factor this and give my linear factorization over the reals,
You just leave.
I would just leave it. Why?
Because when you factor, it becomes imaginary.
It becomes imaginary. Good. Very good. But if I'm going to completely factor this, well, let's solve it. X squared plus 6 equals 0. X squared plus 1 equals 0. I'm going to subtract 6 from both sides. X squared equals negative 6. Take the square root, right? So here, I get x equals plus or minus 6i. Agreed?
Yeah.
Here,
Why'd you take the 6 out of the root?
I didn't mean to. You're right. I'm sorry. I root 6. Yeah, no, you're right. Thank you, sir. I root 6. Over here, what am I going to get? Minus 1 minus 1. So x squared equals negative 1. Take the square root. I get x equals plus or minus I. These are my roots. These are my solutions. These are my zeros, my x equals. If I was going to write them as factors, it would be x plus I root 6, x minus I root 6, x plus I, x minus I.
Miss Meadows.
Mm-hmm.
Why is it plus negative I, plus and minus I, instead of plus and minus I with a radical 1?
What's the square root of 1?
1.
That's why. If you were to write I root 1, I mean, technically that's right, but WebAssign will mark it wrong. Because the square root of 1 is 1, so the most simplified version would just be I. Plus or minus.
Would they ask for zeros in this situation too?
What would the zeros be? If they ask for the roots or the solutions, it would be your imaginary ones. If they ask for the real zeros or the real solutions, you would say there weren't any real ones. Just got to be careful with what they're asking you for. All right, look at number 4. What's going on with 4? GCF?
No.
No. Can I group this one? We always try and group before we go to synthetic division because grouping's easy. Can I group this one?
Yes.
Yeah. I can take out an x squared, right? I'm left with x minus 3. What can I take out of negative 2x and a positive 6?
Negative 2.
Take out a negative 2, and I'm left with x minus 3. So guys, when we factor by grouping, what do they each have in common now?
They have an x minus 3.
They have an x minus 3. So we're going to take that x minus 3 out in front. We write it one time. And then what happens to the leftovers?
X squared, times x squared, no.
Minus 2, right? All right, so let's solve this. X minus 3 equals 0. X squared minus 2 equals 0. Add 3 to both sides. X equals 3. Add 2 to both sides. X squared equals 2. Now what? Square root, right? So x equals plus or minus root 2. How many real solutions do I have?
3.
3. The square root of 2 is a real number. It's a real solution. It's not a pretty one, but it's real. So if I was going to write my linear factorization, I have 3 parentheses. If I move this 3 back over here, what does it become?
X minus 3.
X minus 3. And then what does my next 2 parentheses look like?
Plus plus square root of 2 and minus square root of 2.
Perfect. Very good.
Miss Meadows.
Uh-huh.
Why didn't we factor by grouping in number 2?
So, if we group this, right, what would you take out of the first parenthesis? X squared?
Yeah.
And I'd be left with x minus 7.
Mm-hmm.
And then what would you take out of the second parenthesis? A 2?
Yeah.
And you'd be left with x plus 20. Right?
Yeah.
In order for grouping to work, these two have to be the same. Yep, because look, what's left over is x squared plus 2, and that's not what we had down here. It was x squared minus 2, right?
Mm-hmm.
Good question. That's why I always say try to group first, because sometimes you luck out and you can, and you're like, oh, thank goodness, I don't have to do synthetic division, but sometimes you can't. But remember, when you group, you want the parentheses that are left over, that you like once you take the GCF out, the parenthesis that's left needs to be the same in the first term and the second term.